This sounds like boring museum history, until you realize modern scientists, engineers, and chemists genuinely cannot fully explain and still can't fully recreate some of it. 5 inventions from the ancient world where the debate is still alive, the science is still incomplete, and in some cases, the harder we look, the weirder it gets. We're going to go through each one, talk about what we actually know, what we still can't explain, and why some of this knowledge disappeared in the first place. Because that part, why it disappeared, is honestly the most interesting part of all of this. Let's start with the one that changes the most the closer you look at it. Greek fire, around 672 AD, and a massive Arab fleet is closing in on Constantinople. The Byzantines are outnumbered, outgunned, and running out of options. Then they deploy something nobody in that fleet had ever seen before. Bronze tubes mounted on the prows of their ships start pumping out a pressurized stream of liquid that ignites on contact and sticks to everything it touches. Ships start burning. Sailors jump into the water, and it follows them. It burns on the water. The Arab fleet is destroyed, and Constantinople survives. The formula for Greek fire was so protected that the people who mixed the chemical, the people who built the siphons, and the people who operated them in battle were 3 completely separate groups. None of them had the full picture. That was deliberate. It wasn't lost by accident. It was engineered to be unrecoverable if any one part of the chain was captured. And it worked. We still don't have it. What makes it chemically strange is this. It burns on water, and it could only be extinguished by vinegar, sand, or urine, never water. That combination of properties, sticks to surfaces, ignites on water, can't be put out with water, is something modern chemists have not been able to fully reproduce simultaneously. The best guesses involve naphtha, sulfur, quicklime, and possibly saltpeter. You can combine those things and get a nasty incendiary. But matching every reported property at once? Nobody's done it, and there's no physical sample to test anywhere in the world, and because the stuff was completely consumed every time it was used. No residue, no leftover material, just accounts from people watching ships burn. It probably wasn't even one fixed formula. Evidence suggests the mixture evolved over centuries and varied depending on the use case. Ship-mounted siphons versus hand-thrown pots versus whatever else they were experimenting with. So there may not be a single correct recipe to even find. The thing we're looking for might not exist as one thing. But that's nothing compared to what happened with Roman concrete, because at least with Greek fire we understand what we're missing. With Roman concrete, we spent 2,000 years thinking we understood it, and we were wrong. Roman concrete is still standing. Structures built 2,000 years ago, submerged in seawater, are not just intact, they're getting stronger. Modern marine concrete starts crumbling within decades. Roman marine structures are actively growing new reinforcing minerals inside themselves, and we only figured out the main reason why in the last couple of years. The key was something called hot mixing. Instead of using slaked lime the way every modern concrete recipe assumes you should, Roman engineers used quicklime, raw, highly reactive, caustic quicklime, and mixed it directly with the other materials at high temperature. Modern builders are taught that's bad practice. It creates an uneven mixture. But that flaw left behind tiny pockets of unreacted lime scattered throughout the concrete as small white grains called lime clasts. And those clasts are the whole secret. When a crack forms in the concrete, water gets in, dissolves the lime clasts, and they recrystallize, filling the crack before it can spread. The concrete heals itself. That property is completely absent from modern concrete. We've been making inferior concrete for 2,000 years because we assumed the Romans were doing it the same way we do, just less precisely. And here's the part that genuinely surprised researchers. Our only surviving ancient manual on Roman construction, Vitruvius, doesn't mention hot mixing at all. The most important step in the process isn't in the instructions, which means either Vitruvius didn't know, or it was considered too obvious to write down, or it was kept out of the text on purpose. We don't know which. In seawater specifically, an extremely rare mineral called aluminous tobermorite keeps crystallizing inside the structures for centuries after they're built. In a lab, you need very high temperatures to synthesize that mineral. Geologist Marie Jackson, who studied this extensively, put it pretty directly. Nobody has produced tobermorite at 20 degrees Celsius, except the Romans. Seawater percolating through the structure dissolves volcanic ash components and grows new crystals from the leached fluid. The seawater isn't destroying it, it's feeding it. The volcanic ash itself came from one specific geological region near Vesuvius, and its reactive chemistry isn't something you can just substitute with generic ash. So even now that we've mapped the mechanism in detail, and 2023 and 2025 papers have gotten pretty precise about this, nobody has industrially reproduced Roman-grade concrete at Roman cost and scale. The knowledge of how it works came back. The ability to actually make it at scale hasn't. If you're finding this as interesting as I am, stick around. The next 3 are where things get genuinely weird, and one of them involves nanotechnology that nobody intended to invent: Damascus Steel. The blades made from it were legendary for combining two things that shouldn't coexist: extreme hardness and real flexibility. Most steel that's hard enough to hold a sharp edge is brittle. Damascus steel wasn't, and the surface had this flowing, watered pattern that nobody could fake. Smiths who tried to copy it for centuries couldn't get it right, and eventually the technique just stopped being used. By the 1700s or 1800s, it was gone. Here's the part that changes how you think about the whole story. The Smiths in Damascus never actually made the steel. They imported it as ingots from specific mining regions in India, a material called woots. When the ore supply from those regions changed, the steel changed. The technique didn't disappear because someone forgot a secret. The supply chain collapsed, and the specific ore chemistry that made the whole thing work stopped being available. That ore chemistry matters more than anyone realized, because in 2006, researchers put a genuine 17th century Damascus blade under a high-resolution electron microscope and reported carbon nanotubes growing inside it. Carbon nanotubes, in a sword from the 1600s, alongside cementite nanowires that helped create the banding pattern. The Smiths were accidentally doing nanotechnology through centuries of empirical trial and error, using organic forge additives, specific wood species, specific plant leaves, without having any idea what was happening at the molecular level. The carbon content in wood steel sits around 1.5%, which by normal metallurgical rules should have made it brittle and useless for a weapon. It didn't. And the reason involves a very narrow window of trace elements, particularly vanadium, that had to be present in the original ore at just the right level. Too much or too little, and the pattern doesn't form. The process was so dependent on that specific ore from that specific region that when the mining and trade routes were disrupted by colonial era changes in the 1700s, the whole thing ended. Not because knowledge was lost, but because the raw material that made the knowledge work was gone. Modern metallurgists can produce nanotube-bearing ultra-high carbon steel in controlled lab conditions. But nobody has reliably reproduced the actual historical Woots to Damascus process at forge scale, repeatably, with consistent results. The mechanism is understood, the replication isn't there yet, and then there's the one that might not be what anyone thinks it is, or might be exactly what it looks like, and we just can't prove it either way. The Baghdad Battery. Discovered in the 1930s near Baghdad, it's a clay jar about 5 inches tall containing a copper cylinder, an iron rod, and an asphalt seal. That combination, copper, iron, electrolyte, is structurally almost identical to a basic galvanic cell, a battery, which is exactly why this debate has been going on for nearly a century and shows no sign of stopping. Reconstructions using a similar setup with an acidic liquid like grape juice produce around 1 volt of electricity. That's real, measurable current from an ancient artifact. But here's the problem. Nobody has ever found a wire. No evidence of ancient electrical wiring, no downstream device that could have used the current, nothing in any text or inscription from the era that mentions electricity, shocks, or anything like galvanic experimentation. If this thing was generating power, there's no trace of what it was powering. The most popular theory is that it was used for electroplating metal, coating objects in a thin layer of gold or silver using electrical current. But 1 volt is almost certainly not enough for that, and objects once cited as evidence of ancient electroplating were later found to be fire-gilded using mercury, which is a completely different process with no electricity involved. Some early replication experiments claim to show electroplating working, but those results were poorly documented and haven't held up well. The mainstream archaeological position is that it was probably a scroll jar, used to store rolled papyrus documents. That's a reasonable explanation. But the case isn't closed, because the battery interpretation hasn't been definitively ruled out either. It's genuinely unresolved, and the artifact itself may now be permanently unrecoverable for further testing. It was looted from Iraq's National Museum during the 2003 invasion, and its current location and condition are unknown. So we have an artifact that might be a battery, might be a jar, generated real electricity in reconstructions, has no surviving downstream evidence of what it could have powered, and may now be gone. That's where the case stands. The next one is not a mystery of chemistry. It's a mystery of precision, and it's a lot more violent. The Antikythera Mechanism. It's 1901, and a group of Greek sponge divers are pulling artifacts from a shipwreck off a small island. The ship went down around 65 BC. Among the corroded bronze statues and amphoras, someone pulls up what looks like a lump of rock and throws it in a box. It sits in a museum for months. Then an archaeologist notices the lump has cracked open, and inside are tiny, interlocking, precision-cut bronze gears in a device over 2,000 years old. What they had was essentially an analog computer. At least 30 gears arranged in a system that could predict solar and lunar eclipses, track planetary positions, and model the moon's irregular orbit, which requires genuinely advanced mathematics to pull off. After this thing was built, humanity didn't produce anything mechanically comparable for another 1,400 years. That's the gap, 14 centuries, and we still don't fully understand it. Here's where it gets strange. In 2024, researchers had to borrow statistical techniques from gravitational wave astronomy, the same math used to detect black hole collisions, just to figure out how many holes were in a broken calendar ring on the device. They landed on 354 to 355, which matches a lunar year almost exactly. That's a 2024 discovery about a 2,100-year-old object. And the gear system inside contains an epicyclic differential concept that historians assumed wasn't invented until the 1500s. One artifact just rewrote that entire timeline. But here's what nobody can explain. How did 2nd century BC craftsmen cut gears to that level of precision without anything resembling modern tooling? We can build working replicas now. We understand the gear logic. What we can't reverse engineer is the manufacturing process that made it possible. And a 2025 simulation suggested the device may have actually jammed periodically because of its triangular gear teeth and structural imperfections. So we're not even sure it ran smoothly. We know what it was supposed to do. We're still arguing about whether it fully did it. And it was found on a ship, being transported somewhere. So this wasn't a one-off miracle someone built in a cave. Somebody was casually shipping this across the Mediterranean. How many more existed? How many are sitting at the bottom of the ocean right now? Here's what's interesting when you look at all 5 of these together. These aren't cases of knowledge being stolen or suppressed. They're cases of knowledge being fragile, dependent on specific people, specific materials, specific trade routes, or specific conditions that, once gone, took the knowledge with them. And in some cases, like Roman concrete, we spent 2,000 years assuming we already understood it, which meant nobody was asking the right questions. What's changed in the last few years is that we're finally asking them. The gravitational wave math applied to a 2,000-year-old gear ring. The 2023 and 2025 papers on Roman concrete's self-healing chemistry. The electron microscope revealing carbon nanotubes in a medieval sword. We're getting closer on all of these, but closer still leaves real gaps. And those gaps are what make this stuff genuinely interesting rather than just historically curious. And if this kind of thing is your thing, subscribing actually helps because this is the lane the channel lives in. Drop a comment which one you think is the most unsolved. Greek fire, Roman concrete, Damascus steel, the Baghdad Battery, or the Antikythera Mechanism. That debate is worth having. The honest takeaway from all of this is that the ancient world was not primitive. It was doing things we still can't fully replicate, through methods we're still reverse engineering, with materials we're still trying to source. And the fact that some of it disappeared doesn't make it mystical. It makes it a real engineering and historical puzzle, which is actually more interesting, because puzzles can be solved. We're just not there yet.